I'm Professor Rad, and this is Precalc video 1-2, outside transformations. In this and the next, I think it's 3 additional videos, we'll be talking about different transformations that you can perform on functions. So in this video, we're talking about outside transformations. There are also inside transformations that can occur. And when we're referring to outside and inside transformations, we are referring to the algebraic expression of those functions. So I have a few examples here of different ways that we'll be transforming functions in this course. And I wanted to talk a little bit about the difference between outside versus inside transformations. So if I look at these functions in this first column, these are all inside transformations. This means that anything we're doing to kind of shake up or change the basic or root function is happening inside the function itself. It's happening before the main action of the function. So for example, here we have f of x plus 2. This plus 2 is happening inside those function parentheses. So that's an inside transformation. In this one here, now we don't have like an f of x, we have an actual defined function. And if I look at it, it's basically something being squared. So this here is a transformation on x squared. So x squared is our basic function. This plus 2 is happening to the x part. It's not happening to the squared part. So it's happening before we do the action. It's happening before the squaring. So this transformation is happening inside. We can compare these to outside transformations. So this list here in this column, these are outside transformations. So notice on this first one, we have f of x happening, and then we have plus 2. So the plus 2 is happening outside of the function, right? The function happens first, and then the plus 2 happens afterwards. Similarly, we have an x squared plus 2. So the main basic function of x squared happens, and then we add 2 to it. So that's what I mean by the difference between inside and outside transformations. So like if we look at this next 2 to compare, it looks like the basic function happening here is the absolute value of x, and then we're transforming it somehow by multiplying by 2. So in this case here, that 2x is happening inside the absolute value bars. So that's an inside transformation. Whereas over here, the absolute value of x happens first, and this 2 is multiplying outside of that. So that's what makes that an outside transformation. Similarly, when we look at these cubed root type of functions, the cubed root is the main action here, as is the cubed root here. So these are both transformations on the cubed root of x. In this example, we're negating x, adding 5, all before we get to that main action of cubed rooting. So this is all inside the cubed root radical, so these are inside transformations. Whereas over here, the cubed root of x happens, but then we have this negating of that and adding of 5 outside the cubed root function. So these are outside transformations. So in this video, we'll be looking at outside transformations because they're a little bit easier to talk about. And then in the next video, we'll talk about inside transformations. In the third video of our transformation sequence, we'll talk about reflections. And then in the last video, we'll combine all of them together. So we want to focus first on the fundamentals. So we're going to look at outside transformations first in this video. So I'm going to start out by giving a list of general guidelines to follow with outside transformations, and then we'll do a few examples. So here are our general guidelines for outside transformations. If you want to take a moment and pause the video here to copy those down in your notebook, you can do that, or you can copy them down as we're talking about them, whatever works for you, I guess. So outside transformations are going to end up graphically representing a vertical change. So yeah, so if the transformation's outside the function, it'll have a vertical impact. When we're performing these outside transformations, it's going to follow your intuition. It's going to do what you expect it to do. And we're going to follow the order of operations that will impact the order in which we perform the operations or the transformations. Now, whenever you're performing a transformation, if you add or subtract a value, that's going to result in a shift. And if you multiply or divide by a number, that's going to result in either stretching or shrinking. So if we follow our intuition, if you add a value to a function, adding is positive, and we usually associate up with positive. So if you add a number, that's going to result in a vertical shift. And if you subtract a number, that's going to result in a downward shift. Similarly, if you multiply by a big number like 7, it's not that big, but if you multiply by a number like 7, that's going to result in a vertical stretching. So you'll see the function, maybe it starts out like this. If we stretch it by 7, all those y values are going to get multiplied by 7. So it's going to stretch vertically. Similarly, if we divide, which usually means multiplying by a value between 0 and 1, so if we multiply by a half, then we're going to take that function and we're going to shrink it vertically by half. So these are the main basic tenets you want to keep in mind when working with outside transformations. We're going to do a few examples. Some of them will start out with a weird looking function and then we'll transform it. And other times we'll start out with one of our common basic functions we talked about in the last video, and we will transform that one. So our first one, I think, is actually going to start out with one of our basic common functions. I chose to use which one? Cubed root of x? Cubed root of x. So what I'm going to do to help us out, I'm going to copy these kind of in an abbreviated format over here, so we have them for reference. And I'm going to redraw the graph of the cubed root of x function for reference. So if you want to take a moment and review the cubed root of x to prepare for this example, you can do that. Pause the video and do that. For our first example, we've been asked to graph the cubed root of x plus 2. So what we're going to do is we're going to use the base graph of cubed root of x, and we're going to transform it accordingly based off of this transformation that's happening. Now, before we do that, I do want to take a moment and say, well, couldn't we just like plug in points and graph it if we were going to graph it by hand? I mean, we could also just throw this in a calculator, right? So those are true. If I wanted to graph this function, that's probably actually the way that I would do it. I'd probably pick points and, sketch the graph that way. So the reason we're using this particular graph for this example is because in the future, we're going to be looking at messier functions like sine function or a tangent function, and we're going to need to know how to do transformations on those functions in order to graph them more easily. So it turns out in those situations that the transformations are a lot easier than trying to find, a table of points, because it's not always clear what points are going to be really nice to use. So for right now, we're using a function where a different technique might seem easier, so that if we wanted to check our work, we could use that easier, technique and be confident in our answers. So we're building up this skill on easier types of functions so that we're confident in that skill set, so that when we get to more challenging functions, we feel confident in our approach. We'll also be doing some examples where the only way to graph the transformation is to use this technique I'm going to show you in this example. So again, we're trying to build up a different set of skills that we might not have used before. So all that being said, in order to graph the cubed root of x plus 2, I know this is an outside transformation because the plus 2 is outside the main function of cubing root. So that means it's going to have a vertical impact and it's going to follow my intuition. So adding means a shift, multiplying means a scaling, right? So adding is a shift, and my intuition says if I'm adding 2, that ought to shift it up by 2. So you could memorize these kinds of things, but if you remember those general concepts, add is a shift, multiply is a stretch, and vertical transformations follow your intuition. If you remember those general guidelines, it'll be a little bit easier. So here's my basic function of the cubed root of x, and I'm going to take this function and I'm going to shift it up by 2. So before I do that, I need to create some graphing space for me to work on. And in order to create the grid, to know how wide or narrow or whatever I need to make it, I'm going to think about the change that this function will have. So this function is going to have no change in the left to right orientation, but it is going to move up 2 spaces. So because I'm going to be moving it up 2, I'm going to scale my axes in the same way. What I mean by that is I'm going to move what my lowest and highest y values were by shifting those up 2. So instead of -4, I'm going to start at -2, and instead of stopping at 4, I'm going to stop at 6. Just going to shift my axis basically. So I apologize for my squeaky markers today. So I'm going to start down here at -2 instead of -4, and I'm going to go up to 6. And then my horizontal axis is going to remain the same. So my horizontal axis, I was counting by 2s. So 2, 4, 6, 8, 4, 6. There we go. So that's one way to create your axes. You do want to make sure that you don't always just default to using whatever your basic set of axes were for your root function, because especially if we're stretching or shrinking, it could be very difficult to do that on a like stoic or stationary plane. Next, to do this transformation, I'm going to find some points on the function that are clear, easy to read, easy to see, and then just do the appropriate transformation. In other words, I'm going to shift those points up by 2. So over here, I have a point at -8, -2. And if I transform it by shifting it up 2, I'm at the point -8, 0. So that's the first point I'm going to graph for this transformed function. And I'm going to do that to every point. So here I have the point -1, -1. If I shift it up 2, I'm now at -1, 1. So I'm going to go over to -1, 1. This point at 0, 0, when I shift it up 2, becomes 0, 2. This point at 1, 1, shifted up 2, becomes the point 1, 3. 1 is here. So 1, 3. And then my last nice point was at 8, 2. And if I shift it up 2, becomes 8, 4. And now I'm going to connect those points in the same way that they were connected over here. So we had that nice little shimmy going on. So we're going to connect them with the shimmy. So this is our transformed function of the cubed root of x plus 2. I was a little bit sloppy in how I connected them, but hopefully you get the idea. So that's a shift. Let's do an example where we have a stretch. Sometimes the stretch can be a little bit harder to figure out what's going on than the shift. And I guess I should mention also, if I look at this and I shifted it up 2, this is what I would get, right? That kind of matches our expectation. Okay, so let's do one that's going to involve a shift or a stretch. Let's do one that involves a stretch. For our second example, we've been asked to graph this new function g of x, which is equal to 2f of x. So we know this is an outside transformation because the 2 is outside the function. And because it's outside, we know it's going to have a vertical impact and follow our intuition. So since we're multiplying by 2, that means we're going to stretch vertically by a factor of 2. Now, if I look at the function that I'm transforming, this time instead of having an algebraic expression, we have a graph. So we're just going to transform the graph of this function as we've been dictated to do. In order for us to do this, we have to draw our new coordinate plane to graph on. So remember, we want to think about the impact that the transformation will have on the function to help us draw our grid. In this case, because we're multiplying by a 2, that means we're going to have to stretch vertically. So all our y values are going to get doubled. So I'm going to give myself a little note here that 2 times, that means we're going to have to multiply all the y values by 2. And this actually really makes sense because remember f of x just means y. So we have 2y here. So we're just multiplying the y's by 2. So when I think about the impact that's going to have on my graph, I'm going to look to see where the lowest point is and where the highest point is. So my lowest point is here at -1, -1. And the highest point is over here at 3, 3. In order to graph this, we're going to have to multiply all y values by 2, which means if I want to figure out the transformation that's happening, if I multiply the lowest y value by 2 and the highest y value by 2, that'll give me a good idea of the space I need to graph. So multiplying that by 2, I get -2, and multiplying 3 by 2, I get 6. So when I go to create my graphing space, I want to make sure that the vertical axis goes at least down to -2 and at least up to 6. There is no horizontal change, so I don't have to change the horizontal axis. So I usually like to give myself a little bit of buffer space. So I'm probably going to go down to -4 and up to 8. But as long as you hit at least -2 and +6, you should be good to go for graphing this. So, 2. There we go. So to graph our transformed function, I'm going to do the same thing I did before. I'm going to figure out where each of these nice points, we've got 1, 2, 3, 4 nice points, I'm going to figure out where each of those goes. So this point here is at -3, 0. The transformation that's happening is the y value gets multiplied by 2. So 2 times 0 is 0, which means this point is going to remain fixed. It doesn't move. The second point was at -1, -1, which we were looking at here. When we get the transformation to happen, that means the y value gets multiplied by 2. So it's now going to be the point -1, -2. So I plot the point -1, -2. This point here was at 1, 0. So if I double the y value, 2 times 0, well, that's still 0. I'm going to plot the point 1, 0. And then this point up here was 3, 3. And if I double the y value, 3 times 2 is 6. So it now becomes the point 3, 6. Oh, but it was an open circle, so I got to make sure I graph it with an open circle. And now we connect our points as they were connected on the original graph. As a check to make sure we did this appropriately, it should look like we took this function and we stretched it vertically. So notice how this function looks a little bit wider than this one, because this one was a little bit squatter. So when we stretched it, that thinned it out a little bit. And if I look at the y values, the highest value here was 3. So if we double the function by stretching it, then its highest point should also be twice as high as the original. So we got one more example of outside transformations. So what happens if we have both a shift and a stretch? How does that impact our graph? So let's find out. For our third example here, we've been asked to graph g of x equals 1/2 f of x minus 3. So, and here f of x has been graphed to the side. So if you want to pause and sketch that graph for reference, you can do that now. Okay, so to sketch the graph of 1/2 f of x minus 3, we know these are all vertical transformations because the 1/2 is outside the function f of x, as is the minus 3. So because these are outside transformations, they're vertical changes, and we need to follow our intuition. They're going to work the way we want them to. What that means is when I go to find the order of these transformations, we're going to follow the order of operations. So the order of operations says you multiply before you add. So here we have to deal with the transformation that comes from multiplying before we deal with the transformation that comes from adding. So first, when I multiply by 1/2, what that's going to do, because 1/2 is less than 1, instead of stretching vertically, it's going to shrink it vertically. So first, we're going to have to shrink vertically by 1/2. In other words, we're going to multiply all the y values by 1/2. Second, we have this -3. So that means, because we are subtracting, this is going to be a shift downwards. So after we shrink everything by 1/2, we're going to shift down by 3. Great. So this is kind of like a roadmap, if you will. This is telling us what we're going to need to do to each of these nice points that have been graphed for us in order to graph g of x. Now, when you have multiple transformations, it can be a little bit trickier to figure out what's going to end up happening to your vertical axis. So I usually like to check a little bit what's going to happen to the extreme points. So to do that, we could make like, yeah, why don't we do that? Why don't we make like a little table to help us figure out what's going to happen to these points? So what I'm going to do is I'm going to have the original point. Then I'm going to have, after my first step, so I'm going to have the shrink. And then after the second part, we're going to have the shift. So what I'm going to do is I'm going to list all of my original points here for reference. So we have -3, -2, -2, 0, 0, 2, 2, 0, and then 3, 2. So those are going to be all of our original points that we'll be transforming. So if I think about what's going to happen to this, first we're going to shrink it vertically. So that means we're going to cut all of the y values in half. So half of -2 is going to be -1. Half of 0 stays the same, that's going to be 0. Half of 2 is 1. Half of 0 is 0 again. And half of 2 is 1. So notice again, because this is a vertical change, it's only going to impact the y values. The x values have no impact. So here we're doing half of y. It's basically what we're doing. Okay, so we took half of -2, half of 0, and so on. Now we're going to shift down by 3. So this is where the visualization works a little bit better for me instead of like thinking of the arithmetical change. So if I have the point -3, -1, and I shift it down by 3, that's going to bring me down 1, 2, 3. That's going to bring me down to -4. So this point will now be -3, -4. If I have the point -2, 0, and I shift that down 3, 1, 2, 3, we're now at -2, -3. I'm at 0, 1, and now I go down 3, 1, 2, 3. I'm at 0, -2. If I'm at 2, 0, and I go down 3, 1, 2, 3, I'm now at 2, -3. And if I'm at 3, 1, 3, 1, and I go down 3, 1, 2, 3, I'm at 3, -2. Okay, so that's going to be after we do our shrink, excuse me, then we do our shift. So because we're doing these transformations in order, that's why I did this shifting part based off of the shrink point, not the original. right? Because we do the shrinking first, and then we do the shifting. So now that I have these key points that we're going to be graphing, I can use that to help me figure out my vertical axis. So in this case, oh golly, we've all got negative points going from -4 to -2. So I just need to make sure that I have a lot of negative space on my grid, I guess. And the x-axis is going to remain the same. So we're going to go from -4 to 4 again, it looks like. I'll give myself plenty of negative space here. And lastly, we're just going to plot those points that we found. So we're going to, this is what we're graphing, that final column, because that's the final transformation that took place. So we're going to graph -3, -4. All the way down here. -2, -3. 0, -2. 2, -3. And 3, -2. And then we're going to connect them in the manner that they were originally connected. So these points were connected by straight line segments and they have arrows on either end. So we need to make sure to include that. So this piece, and then that one, and then that one. There you go. That's our function g of x. And as a quick, guess or like reasonableness check, it does look like I took this function and I shrank it in half and then I shifted it down. So that matches what I expected to see in this graph. Now, the ultimate goal in this whole process is to move immediately from the graph to the graph. In other words, the goal is you want to become more familiar with these transformations so that you can kind of do them mentally or initially on the original function. So here's what I mean by that. Once I identify these two steps, I ought to be able to jump from here to here without having to write points. So if I know that I'm shrinking the vertical value by a half and then shifting down by 3, here's how I would do that. So I would start at this point, -3, -2. Shrink it by half means I have to cut this value in half. So I'm at -1. Then I shift down 3. 1, 2, 3. So that would be this point here. Then I'm at -2, 0. I cut 0 in half to get 0, and then I move down 1, 2, 3. So now I'm at -2, -3. That point there. At this point, I cut the 2 in half because that's the y value. So half of 2 is 1. And then we go down 3. 1, 2, 3. So we're now at 0, -2. And similarly, we follow the next 2 points. The y value is 0. So half of 0 is 0. 1, 2, 3. 2, -3. And here the y value is 2. Half of 2 is 1. And then we go down 3, 1, 2, 3. So 3, -2. So you can see that I can perform these operations kind of visually on this original graph, and that will get me those same points without having to write this table here. So for my classes, if you're not in my class, you want to check with your teacher what they expect to see. But for my classes, all I need to see is this final graph. As you're practicing and building up these skills, if it helps you to create a table like this, absolutely do so. I guess I misspoke. In addition to the graph, I do also need to see this. I need to see what your steps are, what your order is, so that I know where this graph came from. So if you have that order implied in your table, that's fine. If you write it out like this and then create your graph, that's also fine. So this would be constituted as full work, or this would be full work. I'm not going to require one or the other. So whichever one you feel more comfortable with, go with that. Okay, so do what is going to work best for you. So that's where we're going to end this video on outside transformations. In the next video, we're basically going to repeat this whole thing, but now for inside transformations instead of outside. So hopefully this video helped you with your vertical transformations, and I will see you for horizontal transformations in the next video. Bye.